Hello dear students, today I'm going to solve ISI GRF 2023 and this is the first question which we have. So I will solve it in three parts. First is if f of 0 to 1 is a function such that fx equal to 1 minus root over 1 minus x square, so that 1 minus f of 1 of 1 minus x equal to x. So now how to do it? So here first we have to do a little bit of calculation. So we have to simply substitute the expression fx into the equation to simplify. So here we have 1 f of 1 minus of fx, this thing, 1 root over 1 minus x square and this square. Okay, so this is a root over 1 minus 1 root over 1 minus x square whole square. So now we have this root, this 2 root over 1 minus x square, 1 minus x square. Okay, so now if this thing continues, so the very next step, this will be root 2, so this 2 comes out, so 2 1 minus x square whole to the power 1 by 4 we can get. Okay, so finally 1 minus x square whole to the power 1 by 4. This part is done. To simplify further, we can square both sides of the equation. So it's like 1 minus f of 1 minus fx square equal to 1 minus x square and 1 by 4 square. So this value will be x square. So expanding the left side and substitute the expression of fx, we get it's like 1 f of 1 minus fx square 1. So in this case 1 minus fx of x square we have. So let's go for a little bit of simplification, which is very much needed. So 1 root over of 1 minus x square 1 minus x square, this 2 and all to the power 2. So finally 1 this root 1 x square and this is a square. So finally this value will give you 1 minus x square. So therefore we have this value is equal to 1 f of 1 minus fx square equal to 1 minus x to the power 2, taking both the square root of both sides. So 1 minus f of 1 minus fx is plus minus root over 1 minus x square. Since the fx is defined in the interval 0 to 1, it follows that it's also defined on the interval, okay, 0 to 1. So therefore we must have in this case, so greater than equal to 0. Okay, so we can conclude that 1 f fx root over 1 minus x square, so which implies that 1 minus x square. So substituting both sides, we get 1 minus x square equal to 1 minus x square, which is true for all the x interval. Therefore we have shown that 1 minus f of 1 minus fx is equal to x. That's the first part done. Now we go for the second part. Let f of 0 1 is monotonically increasing, so that limit of x tends to fx is infimum of fx where c less than x. So this is a complicated one. So let's go for 1b now. So in this solution, to show that this limit of value, so what is the value? Limit c plus x tends to c plus fx. Okay. So infimum of fx less than cx. So we need to prove two inequalities. So tends to c fx less than equal to infimum of fx given c less than x and limit x tends to c fx greater than equal to infimum of fx given c less than x. So let's start with the first inequality. So here is an equal to infimum of fx given that c less than x. So fx is monotonically increasing, and as a result of that, let it be sigma greater than 0. This also is greater than 0. So 0 mod of x minus c less than sigma. So then fc less than equal to fx less than fc plus. So now if we consider the set here directly is equal to fx of x. Does this set consist of all the functions of fx? So therefore this infima fx mod c less x, this is greater than equal to fc. This is done. So therefore limit x approaches c. So we have this thing. So limit x tends to c fx infima of fx c less than x of 1. Okay. So if we go to the second inequality from this part directly, so and consider the set t equal to f of x given c less than x. So fx is monotonically increasing and all the elements of t are less than or equal to c. So therefore infima fx c less than equal to x less than equal to f of c. So taking the limit as x approaches, so combining this 1 and 2, we conclude that limit x tends to c fx is infima in the proof. The third part we will solve in the next